Good morning to sir. Today I'll be doing 4 stimulation, and now I will start out with the gram staining stimulation. So the gram staining is a concept of differential staining, and the gram staining is used to categorize microorganisms into classifications such as the gram positive and the gram negative. And basically, there are 4 important steps in this gram staining. The first one is primary staining, which uses the crystal violet. The second step is modern stain, that we will use the iodine. The third one is the decolorization step, which uses alcohol, and the fourth one is the counter staining, which we will use the safari. So I will start with the experiment. So we will first sterilize the inoculating loop by putting it into a Bunsen burner, and then we will use the loop to touch the colony, and we'll place the loop into the drop of water. And next we will sterilize the loop before we put it on the bench. And now we will let the water to dry on the side for 5 minutes. So we will continue the gram staining stimulation by heat fixing the slide. So I will now click on the slide, and I will pass this slide gently 2 to 3 times, around 1 or 2 seconds every time through the flame. 1, 2, 3. Okay, we cannot put the slide too long on the flame, so because it will kill the microorganism and will cause the distortion of the cell. So next I will flood the slide with crystal violet and let the liquid to stand for 1 minute. And I will now rinse the slide with the H2O, which is the water. And next I will use the iodine, and I will let the liquid to stand again for 1 minute. Then I will use the H2O to rinse it. And so our next step is we will decolorize with alcohol for 5 to 10 seconds, around that, and we'll then rinse with the water again. So our fourth important step we will use the safari. We'll use the safari and let the liquid stand around 1 minute, and then we'll rinse again with the water. So after we rinse with the water, our slides are ready to be viewed under the microscope. So this is our gram staining under the 1000 magnification. The second stimulation, which is the Catalase Test, is used to detect whether the microorganism contains the enzyme catalase. So where there is bubble formation on the slides, the microorganism will be considered as catalase positive because the microorganism contains the enzyme catalase. But if there is no bubble formed on the slides, the microorganism is called as the catalase negative because it does not contain the enzyme catalase. So I will start off with the first step. So I will first drop the H2O2 on one of the slides. Okay. Next, I will use a toothpick to pick up one isolated colony. So I will choose this. So next I will mix the bacteria into the H2O2. and observe whether there is any bubbles formed. So as you can see here, there is no bubble, so it will be considered as catalase negative. After that, I will throw this toothpick into the disposable tin, and I will dispose this slide into the disposable container. So I will again start off with by dropping 1 drop of H2O2 on the slide. Then I will use a toothpick to pick one colony. And then I will mix the bacteria into the H2O2 and observe. As you can see, there is already bubble forming on top of the slide. So it will be considered as catalase positive. So I will dispose the toothpick. We can see there's air bubbles here. And done with the experiment, I will dispose the slide. So yeah, that. The third stimulation will be the Coagulase Test. This Coagulase Test is used to identify whether the bacteria produce the enzyme coagulase that will attach to the cell wall of bacteria. So whether it's clot or clump on the glass slide, we will know that the bacteria is coagulase positive, and when there is no clump or clot, the bacteria will be called as a coagulase negative. I will start the experiment by dropping the water on top of the slide. Next, I will use a toothpick to pick one isolated colony. Then I will mix the bacteria into the water. After mixing, I will dispose this toothpick and add 2 drops of the rabbit plasma. 1, 2. So next, I will rod slide the slide and observe is there any clumping forming on the slides. So yeah, we can see that the clump is started to form on top of the slide. So it is positive. After done, I will dispose this slide, and I will start off again by dropping the water on the slide. I will use a toothpick to pick one isolated colony. Then I will mix the bacteria into the water. After mixing, I will dispose this toothpick and drop 2 drops of the rabbit plasma. Then rod slide the slide again and see whether these bacteria will form any clump. So if there is no clump, the bacteria is coagulase negative. Then we will lastly dispose the slide, and that's all for coagulase tests. The fourth stimulation will be the oxidase test. So this oxidase test is used to identify whether the microorganism contains the enzyme oxidase. So where there is presence of the enzyme oxidase, the reagent will turn to dark purple in color, and this shows that the microorganism is oxidase positive. But when there is no presence of the enzyme oxidase, the reagent will be colorless instead of becoming dark purple, and this will shows that the microorganism is oxidase negative. So I will start off the stimulation by picking an isolated colony using a sterilized toothpick. Next, I will rub this isolated colony onto the slide to observe if there is any color changes. So when the color change to dark purple, it will be considered as a oxidase positive. After that, I will dispose the toothpick and pick a new one to pick a new isolated colony. Then I will rub the bacteria onto the slide to observe the color. So where there is purple, dark purple color, it is oxidase positive. Next, I will dispose the toothpick, and I will lastly get a new toothpick to pick another isolated colony of the bacteria and rub on the slide and observe the color change. So if the color is dark purple, it will be considered as oxidase positive. Next, I will dispose the toothpick, and after recording our result, I will dispose the dry slide. So done with the oxidase test.